So our last part of this unit is scatter plots and linear trends, but mostly scatter plots. So what a scatter plot is, I'll show you what it looks like right after this. A scatter plot is a graph of ordered pairs used to evaluate a type of relationship that exists between any two variables. That's the fancy way of saying that a scatter plot is a graph of points and you try and figure out what's happening with that data. If I'm looking at the scatter plot of this one, I can see that, oh, it looks like, something's going up. I don't know what it is. Maybe this is how much money you make per hour. As you work more, you make more money. I don't know, but that's what a scatter plot is. It's a bunch of data that's put into a graph and there's no line between it. It's just a bunch of points and that's it. So that's an example of a scatter graph there. So a scatter plot is a type of graph used to discover what relationship exists between two variables. Okay, so it's not the important part about scatter plots are not being able to draw them. The important part about scatter plots are being able to understand what information you can get from that graph. So we're looking to see if a trend or correlation exists. Again, if you're looking at like something like of the stock market, let me actually load that up. No. Images. So if you're looking at something like the stock market, which is an example of this here, oh, look at that, your investments went up. That's the type of stuff that this would be used for. So when you have a graph and when there looks like there's a correlation, when it looks like there's a pattern, you can draw what's called a line of best fit. So this is a line that shows the general trend in the data. It does not need to pass through all the data points, but what you're trying to do is, you want to highlight the stuff I'm highlighting right now. I should have mentioned that earlier. So a line of best fit is drawn so that the same number of points appear above it and below it. So the same number of points appear above it and below it. So if you have 10 data points, you want 5 of them to be above that line and 5 of them to be below that line. Okay, so using a line of best fit, you can figure out all of these different things, whether it's a shape, whether it's a straight line or not, whether it's a good, strong correlation or a weak one, whether it's a positive slope or a negative slope, right? Does it go up or down as you read it? And then if there's any outliers that exist. Well, we're going to come back to an outlier. We're going to come back to this, but this outlier is a data point that lies really far outside the general trend of the data. So let's say, for example, let's imagine I was like 7 feet tall and we had a graph of the average height of people in here. I'm an outlier. I'm just too tall. That doesn't make sense. It doesn't fit like the average. So we'll show you a couple outliers in a second. But so what I want us to do is, so you want to stay on page 55 for what I'm going to go. I'm going to go to page 56. Keep your booklet on 55. So we're going to want to answer these 4 questions right here, based on these graphs that we're about to see. So is it linear or nonlinear? What's the direction of the correlation? Is there a correlation? What's the strength of it? And are there any outliers? So I'm just going to jump down here. I'm going to zoom in. I'm going to zoom out actually for a second. No, sure. So for this first graph here, So for this first graph, is it linear or non-linear? What does that actually mean? What does a linear graph mean? Straight, you betcha. Does it look like there's a straight line here? So if I was to draw a line of best fit here, where again, there's what is it? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 11, 12, 13 points here. So if I was to draw a line that had about half of that above and below it, it kind of looks like a straight line. So this is a linear graph. At least we think it is. We don't know for sure, but that's a good guess. And so that's what scatter plots are, is you're taking your best estimate based on the information that you can see. So next question here is, what's the direction of the correlation? Yeah, positive, absolutely. So when it asks you, what's the direction? Yeah, so to the right of it. Or sorry, no, for this one, not for question one. For later one we will, but right now. So this one is positive. So now the strength of the correlation is kind of a tricky one, especially because we haven't seen many examples before. But so one thing I will say is, do these points look like they're pretty close to that line I made? They look pretty close. I mean, it's not a perfectly straight line. But yeah, this would be what we would call, this is an example of a strong correlation. The reason it's a strong correlation, again, if you remember, correlation is looking to see if there's a general trend. Generally speaking, as we go up this graph, as we go from left to right, we increase. And everything's really, really close to this line. So there's a really strong correlation here. And then finally, for question 4, are there any outliers? Is there anything here that just makes no sense? It's really far away from this line that we've made. Not on this one. No, there's no outliers here. Now, an example of an outlier might be something down here or something up here or up here. Ooh. So yeah, so this right here is an example of an outlier. This right here is an example of an outlier. Like this one has a really nice trend here, something like that. But those two are outliers. So the first graph, no outliers. This graph, absolutely, that has outliers. So now you can flip to your booklet. So I'm going to give you just 1 minute. I want you to answer these 4 questions on these 3 graphs here. So graphs B, C, and D. I want you just to answer those 4 questions. I'll zoom in case you want to just not have to flip your page back and forth on these questions. But 2 minutes, just answer as many of those as you can. Answer these 4 questions on those 3 graphs. Here we go. So what I've done for question B here is I've made a basic line here, but what I'm looking for is, first question was, is it linear, non-linear? This looks linear. This looks like a linear graph here. So I'm just going to put linear. For number 2, it's asking what's the direction of the correlation, if there's any. It's a negative correlation, right? As you go from left to right, it goes down. So I'm just going to put negative. Question 3 asks, what's the strength of the correlation? So in this case, I have points kind of all over the place. That's a lot of distance. There's a lot of points with a lot of distance from my line. So it's a weak correlation. There is a pattern here, but it's very weak. And for my 4th question here, are there any outliers? Yes. There's those 2 outliers. Now, question C is an interesting one. So in this case, is this a linear or non-linear graph? It's non-linear, right? There's no straight line that we can see. I can't even really do like a line of best fit through this. Like that'd be something like that. It doesn't make sense. So this is a non-linear line because there's no real line I can do here. In terms of the correlation, you can either have positive, negative, or You could have none. This is a graph that just doesn't seem to make sense. There's no real pattern that we can see that emerges here. So the third question here was, what's the strength of the correlation? Well, there's no correlation, so I'm just gonna leave it blank. There is none. And then question 4, are there any outliers? Well, there's no correlation, so there's no outliers. So the second you see that there's no correlation, this graph is now useless to you. You can't figure out anything from it. And then question D. So first off, is this a linear or non-linear one? It's non-linear, right? Like this doesn't look like a straight line. This looks like a curved line. Looks like a skateboard ramp, actually. So this is non-linear. That said, it can still have a direction of a correlation. And the correlation here is it's positive. And it looks like there's a very strong one here, right? It fits with our line really, really closely. And then finally, are there any outliers? You could maybe argue this one, but generally speaking, not really. Yeah. So, so Jasmine, you were wondering about the linear and non-linear, right? So yeah, when it's linear, it's going to form some type of a straight line. So if I just get rid of all my points here, if I'm looking at this, like, does it look to be some type of a pattern? Like if I was to take any amount of ruler, like this, if I take a ruler and just play around with it, I can make a straight line. In this case, yeah, it's not so much this is exactly what it's going to be. It's very nuanced. So no situation you see is ever going to be the same with it. So I know that's not much of an answer, but it's just one of those things where we have to look and just do our best guess with. And that can be tricky sometimes. That's why a ruler is usually pretty handy, is you can just mess around, move it around, and eventually you'll kind of maybe see a pattern emerge. So jumping into it here. Okay. So I'm going to go into question. This is on page 58. So I'm just going to be blunt. I don't care about drawing scatter plots. It's just plotting points. We don't need to worry about that. I don't care. We'll get calculators to do it for us, but you're not going to be asked to draw one of these on your final exam. They're going to just give you one and be like, look at it. What does it tell you? That's what you're going to get asked. So we're just going to skip that entirely, because I'm pretty confident everyone here could draw a scatter plot. So next what it's going to give us though, it gives us right now 2 scatter plots, and it doesn't really tell us much about them. Normally when we see a graph, when we look at anything else we've done, we've had some type of clues as to what it's about. It's about a temperature. It's about an electrician's amount of money he makes. They don't give us any information here other than here's a graph. So when we look at this, we need to do our best guess based on that. So so just looking at this graph, what are some similarities that we see? Think about those 4 questions we just asked. We just answered. Do we notice any similarities right from the get-go? And again, those questions on the bottom of page 55 are really good ones to like, those are the things you're looking for when you have scatter plots. So you think they're both linear? Yeah. So there it is. So similarities. That's a good one. Similarities. So 1, they're both linear. They both look like they're linear, right? They seem like they have some type of a straight line that could go through them. Imagine that's a straight line. Is there any other similarities that you can see? Both positive. Anything else? Oh, it can still have a strong one if there's an outlier. Yeah. So okay, so you think this first one's strong? I think it's strong too. Yeah. Again, my line looks awful here because I don't have a ruler, but. So yeah, these do have a similarity, or these do have your first one does have a strong correlation. So I want to go into our differences though. So what's different about these two charts? Yeah. So there's more points. That's one thing. There is an outlier in A, but it doesn't seem like there's an outlier in B. There's another one as well that no one said yet. Kim, you were almost there. This one here. So we do know that there's a trend, but how so? But you're looking at that, you're being like, wow, these points are really far apart, right? I think these are both linear graphs. Like you're thinking it looks like there's like two lines here, like one like this too. Something like that. So one thing we found with graph B here is we do know it's a linear graph. There is a straight line that can go through it, but there's a lot of distance between these points and our line. So it looks like we have a really weak correlation here, but then Kim, you the middle and the bottom. Oh, like there could be a strong area, but this one maybe it's not weak, it's weaker. Like this one's really strong. This one's just maybe not as strong. The weak ones have more distance from your line of best fit. Yeah, like these ones here are a lot closer than these ones here. Again, we're ignoring this outlier. An outlier is something you just like, nope, doesn't matter, doesn't exist. So yeah, what you could say is that the correlate or the strengths are different. So those are some similarities and differences between these two of them, between these two types of graphs. So we're going to bypass this. I don't care about drawing it. We don't need to know how to draw it. I think if I were to put this in front of you, I think everyone here could do it. Well, actually, it's called plotted would be the formal term. Yeah, be plotting the graph. Plotting evil world domination. So we're going to bypass this entirely. We're going to come back to this with calculators to do it for us. But so put a little like star here or something, but I don't care about it right now. We're going to skip it. We're going to go straight to this one. So we're going to actually practice now drawing a line of best fit. So one thing I want you to remember is that the line of best fit, it can be drawn starting at the origin, starting at 0, 0. It doesn't need to be. The line of best fit does not need to go through your data points, but you do want about the same number to be above and below that line. So this is where you need this is where you need a ruler or like another pen, something to draw a straight line. So when you're doing this, the first thing you want to do is count how many dots. You want to figure out how many dots there are on here, how many points are on this. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 points here. And then what you do is you just try and split those up. If I know I have 10 points, I need to try and find a line that's going to have 5 points above it and 5 points below it. You can be off. It could be like 6 and 4, but you generally want to try and keep it so it's close to half. Again, there's not some exact, this is exactly how you do it. It's your best guess. So so what you normally want to do is, and I apologize, Lindsay, you can't really do this right now. You normally want to take your ruler And you want to just kind of like explore, try and find something that looks about right. Just like count how many you have like above it. Oh, I have 4 or 5 above it. Good enough. Everyone's going to look a little bit different. And that's okay. Do you have like, you can use your calculator, for example, anything straight. In this case, it looks like mine starts at the origin because I can see there's a trend of it all going down, right? It looks like there's a trend of it going down. So I can start at my 0, 0. So I've drawn my line of best fit. And again, if I want to double check it, look at, oh, let's look. I have half of my points above it. I have half of my points below it, or around half. Again, 4 and 6 is okay. And then you just draw the line. It's not going to be perfect. You're just trying to show a general trend. There are ways on computers that you can get like a perfect one. We're not computers. It's a complex equation. We don't need to go that deep. Okay. So the next thing it asks us is that it also wants us to write an equation for this line. So remember, when we do an equation, it's always, I'm on page 59. Yeah. I'm going to make this blue. No. Yeah. So whenever we do an equation, we have y equals mx plus b. And all we need to do is we need to figure out our slope. So what our m is. I'm going to put a space for there now. X and then plus b. Is there a y-intercept here? Yeah, it crosses my y-axis here. This blue line I'm drawing on my graph. It crosses this axis at 0, 0. So technically there's a plus 0 here, but because we're lazy, like, hey, I'm going to give you $5 and then I'm going to give you an extra $0. You have $0, or you still have $5, right? So we just ignore it entirely. So there is no y-intercept here. So I know I just need to figure out my slope and then I have my answer. Oops, that's not what I meant to do. So what I need to do to find my slope here is you're going to take, so once you've drawn your line of best fit, you're going to try and find a point on that line. Now, something I really want to mention here, that point, I'm going to zoom in. That point, let me use red for this, does not need to be one of the ones that they've given you. It doesn't need to be one of these black dots. It can be, but when I say point, you're looking for something that intersects on a nice, easy, readable number. So if I'm saying a point, I'm saying something like this, the one I'm circling in red, this could work. This is not a point they gave you, but I can see that this thing here is at 2 at the X and 1 at the Y. That's a nice, clean, easy point you could use. You could use these ones too. Those are also at really nice areas, but you just need a point or two to be able to figure out the slope. So you could either do, so first off, if you have a scatter plot, it has to be a straight line. It's either a straight line or you're going to stop working with it immediately. We see that there's a straight line here. So you can either use this y2 minus y1 all over x2 minus x1. You could do that. Or you could just take a point, do rise over run. M is equal to rise over run, to y over x, right? Because y is rise, x is run. My x in this case, my y is 1. My x is 2 of the point I've selected. It's a half. So I now have my equation. I figured out what my slope is. It's just 1 over 2. I figured out there's no y-intercept. So it's just y equals 1 over 2x. That's my equation of my line. Okay, so your next bit here is I'm going to give you just 2 minutes here to do this on yourself, and I'm going to come walk around. I want you to work on question 3 here. You're doing exactly what we just did. You're drawing a line of best fit, and you're writing an equation for it. So there's 2 questions here. I want you to try and draw a line, and I want you to try and find that equation. I'm going to come check on your progress in 2 minutes. You should have your lines drawn by then.